name is Krzysiek and I am a software engineer in the SPDK Poland team. I am pleased to be presenting SPDK Top demo for all of you today. This application was initially created by Maciek Szwed and presented by John Kariuki last year during our virtual summit. Now, I have started the NVMe over Fabrics target application with 10 CPU cores assigned to it. Let's see what Htop can tell us. Here you can see our SPDK processes with almost full CPU usage. Now you might be thinking, why do I see 100% CPU utilization on all of those? Does SPDK maybe need more cores? What is SPDK really doing here? The answer to those questions lays in how SPDK uses CPU cores. SPDK is based on poll mode design, which, unlike many programs, runs parts of itself repeatedly all of the time, instead of interrupting processor whenever it wants something from the system. Whenever we start a target application, SPDK starts a reactor on each logical core, and those reactors then schedule work to be done. Hence, possible insufficiency in regular top, as it will show core usage to be full most of the time. Now, let's launch SPDK Top. You can already see a lot more values and a nice looking interface. There are three main parts of SPDK Top application. Top menu showing available tabs, main display area with column names and displayed items, and bottom menu showing available actions and currently displayed page of data. Starting off with Threads tab. This is a place where information about running SPDK threads is aggregated. Here we can see names of threads, number of pollers that are being run on each of them, and their busy and idle times. You also probably noticed how one of the items is being highlighted here. You can choose and select a record to invoke a pop-up. It will contain all the information seen in a tab and sometimes a little bit more. In this case, we can additionally see poller information written here at the bottom. Now we can switch to Pollers tab. Here we have all the data about pollers running inside SPDK target application. Much like in Threads tab, we have names and busy idle information here. Pop-up here does not contain any additional info, besides what is shown in the tab. Finally, there is the Cores tab. Here you can find all the information about the core number, how many threads and pollers are running on each core, and also idle and busy timers. The last column, frequency, is strictly connected to the topic of dynamic scheduling, which is going to be explained in detail during the scheduler demo performed by Maciej Szwed. This column, as the name suggests, displays core frequencies if such data is available, and we have enabled the dynamic scheduler. Let's look at the pop-up here. This one is a little bit different because it contains a menu with thread selection. This is to allow user to look at the thread data without a need to switch back and forth between threads and Cores tab. All those numbers look very fancy, but I want to show you now how this application might be used in practice. Let's go through the process of adding BDEVs to our SPDK target. I am going to switch to the Pollers tab now, so you can see new items being added here. Additionally, I want to switch displayed values to show data from the very beginning of SPDK target to highlight new entries. And now for the BDEVs. That is one. And another one. As you can see, after adding two BDEVs, we have another two pollers, BDEV NVMe poll admin queue, running inside our SPDK target application. Now, to give you another use case for SPDK Top, I started some I/O traffic using run and vmf.py script. As you can see, we have some work being done this time. And we can verify that by looking at busy times and comparing them with current idle ones. The run and vmf.py script also configures SPDK target by itself, so you will see a lot of pollers in Pollers tab. You can verify if they are busy or idle by looking at the colored status indicators placed in the rightmost column. Now, I relaunched SPDK with 32 cores this time. The goal is to fill the main display area with more records to then highlight some of the features that you can use to make your experience with this application a little bit better. First is changing the refresh rate. By default, this is set to 1 second, but you can change the value by invoking a little pop-up and then typing a number from 0 to 255. Let's type in 5 seconds for now. The SPDK top will now refresh with newly set value. This is especially useful if you want to analyze what you see before the data changes. You can also type in 0 to see the changes as soon as they are available to SPDK top. Let's set it back to 5 seconds for now. So what else? Let's take a look at sorting. By default, this option is set to the first column in each tab and is indicated by the yellow column name. Let's open the sorting window now. Here you can choose the column of data that is going to be used for sorting items. Let's choose idle column and apply the change. As you can see, the yellow highlighting and order of items have changed. Let's set sorting back to the first column. Now, if you want to focus on some values, you can switch some columns off. You can mark the ones to be displayed inside this filtering menu. Let's turn off thread count and poller count for now. As you can see, those columns have disappeared, so we have a little less text on our screen. But what if we wanted to see all the work that our threads, pollers, and cores have done since the very beginning of our SPDK target? We can achieve that with our little switch under the T key. You have already seen how it works when I was adding bdefs to our SPDK. The values in some columns will change to data measured from the start of SPDK target instead of the difference from the last refresh. Refresh rate, sorting, and column display work identically in all tabs. This is all that I had prepared for this demo. Now, to sum it all up, SPDK top is needed to see what is happening inside the SPDK target application, because it runs in a poll mode instead of interrupt mode, and regular top and Htop would be insufficient here. There are 3 tabs: threads, pollers, and cores, with many different columns. The displayed data can be filtered, sorted, and selected to be shown in one place by invoking a pop-up details window. I also showed you how SPDK top behaves when we are running I/O operations and how pollers appear after adding bdefs to our target. If you have any questions, I'll be happy to answer them during the Q&A session, or you can type them into the Q&A chat. My name is Krzysiek, and I want to thank you for your attention and your time.